All right, adding and subtracting rational expressions. So last lesson we did multiplying and dividing. Now we're going to talk about adding. Again, I guess the one big difference or the one super important thing about adding and subtracting fractions is you have to have a common denominator. Okay? You have to have it. Otherwise, you can't add it. So a lot of what we're going to do is, figure out how do we get that common denominator? How do we figure that out? But if you are given common denominators, it's rather easy. You add the numerators, you keep the denominators the same. So 7 plus 3 over 4x, 10 over 4x. And then I just want you to think, can you divide or simplify anything from 10 and 4? Yes, they both have a factor of 2. So your final answer would be 5 over 2x. Another similar example, if you had 2x over x plus 6 minus 5 over x plus 6. Again, add or subtract your numerators, keep your denominators the same. That's the big difference between adding and subtracting. We cannot do anything with 2x minus 5. We can't simplify anything else. So this is going to be our final answer. Now, like I kind of mentioned beforehand, when you get an uncommon denominator, an unlike denominator, in order to move forward, you have to find one. You have to get one. So what they did here is they said, okay, I'm going to multiply both the top and the bottom by D. And then over here, they said, I'm going to multiply both the top and the bottom by C. Therefore, we get CD on the bottom and we get CD on the bottom. So again, because we have the same thing, you can combine them and get your answer. Again, adding your numerators, keeping your denominators the same. So that's kind of going to be a strategy that I would say we're going to use quite a bit. So let's get into it. If I wanted to find an LCM, a least common multiple, okay, least common multiple. Shorthand, mathematicians, which we all are, like to write stuff in as short a way as possible. And I'm looking at these two numbers, 4x squared minus 16 and 6x squared minus 24x plus 24. So I'm going to try to factor these out. So again, what I see here, I see they both have a factor of 4. So I'm going to factor that out. And then I see, I know x squared minus 4. That's one of those square root ones where if I subtract it and then I add it, that middle term goes away. Over here, again, I would say factor out a 6 to start off with. And then let's see here. If we want to factor that, we're going to get x minus 2 and x minus 2. Negative 2 times negative 2 is positive 4. So I guess the last step is if we looked at 4, we would say, hey, 4 is really 2 times 2 and 6 is 2 times 3. So again, we want to write these as products of primes. That's why we did the 2 and 2 and 2 times 3. And so this is actually 2 times 2 is 2 squared. And so what you want to do is you want to pick your highest, whatever you have, you want to pick the highest value. So I have multiple 2's. I have 2 squared here and I have a 2 here, but 2 squared is higher. So in my answer, I'm going to use 2 squared. Now I only have one single 3. So 3 has to be in my answer. I have x minus 2, but x minus 2 happens twice. But again, the highest, this is actually x minus 2 times x minus 2. We could write this as x minus 2 squared. So again, if I have to pick the highest one, I'm picking the squared one. So x minus 2 squared. And then the only thing that's left is x plus 2. And there's nothing, again, to compare that to. So if I were to try to simplify this, I would say 2 times 2 times 3 is 12, x minus 2 squared, x plus 2. That would be my least common multiple. Okay, let's do an adding with unlike denominators example. 7 over 9x squared plus x over 3x squared plus 3x. So again, I'm trying to find the least common denominator. And the only way that I think that I can accomplish this is if I start by kind of trying to determine a common denominator. Now, before I kind of jump into that, I'm going to say, hey, I think I can simplify this left side. I think I could factor something out. They both have a 3 and they both have an x. So I'm just left with x plus 1 over here. And now I need to think, okay, what do I need to multiply by so that I get the same thing? Right now, I've got something on the bottom here, and right now I've got something different on the bottom here. So I think that if I multiply this left side, and anything I do on the top, I have to do on the bottom. So I'm going to multiply it by x plus 1 on both sides. Therefore, I'm left with 9x squared x plus 1 over here, and this is still 7x plus 1 here. Plus, now again, my goal is to end up with what I just got right here. So I'm going to say, well, what do I have to multiply this equation by to get that? I only need to get to 9x squared. So if I multiply the top and the bottom by an x squared, oh, excuse me, that's not correct. If I multiply it by 3x, now I'm going to have 3x times 3x is 9x, and x plus 1 stays the same, and 3x times x is 3x squared. Well, now since we have a common denominator, we can simplify it, and I'm going to go ahead and distribute. So again, distribute this 7, so it's 7x plus 7 plus 3x squared all over 9x squared x plus 1. I'm going to put this in order. So again, my highest exponent goes first, all over 9x squared x plus 1. If you could go any further, you could try to simplify that, but that is going to be as far as we can go. Couple more examples, subtracting with unlike denominators. So again, x plus 2 over 2x minus 2, subtract negative 2x minus 1 over x squared minus 4x plus 3. First thing I'm going to do is I'm going to factor my denominator and just see if I can simplify anything. So the top stays the same. I can factor out a 2 here. Again, I can't do anything up top. If I think about my factor x, well, it's going to multiply to get 3, but add to get negative 4. That's negative 3 and negative 1. So I'm going to have x minus 3, x minus 1. And again, why did we do that? Because if we look here, we've got an x minus 1 and an x minus 1. So that's going to help us. It's going to help us simplify. So the only thing that I have to multiply on the bottom of my left hand side is I'm going to multiply it by x minus 3 on the top and x minus 3 on the bottom. Whereas on the right side, I already have that. What I need to multiply by, we can stay with red, is I need to get that 2. So I'm going to multiply by 2 on the top and on the bottom. So if I rewrite this problem, I have x plus 2 times x minus 3 all over, and then that's going to be subtracting 4x. So you're subtracting negative 4x minus 2, and it's all going to be over 2x minus 1 x minus 3. So I believe we're going to have to simplify and try to combine some stuff. So to do that, I'm going to do my foiling method. Take the outside, multiply it by everything. Take the inside, multiply it by everything. X squared minus 3x plus 2x minus 6 minus, what would this be? Negative 4x minus 2. And then all over, again, this has parentheses around it, all over 2x minus 1, x minus 3. Simplifying, x squared minus x minus 6. Remember, this negative gets distributed, so it's going to change our signs. So negative times a negative is positive, and positive. So much room for error in these. So you have to take it slow, find out what's common. We've got x's and we've got constants. So we have x squared plus 3x minus 4 all over 2, x minus 1, x minus 3. Again, how do I simplify this? Do my factor x for the top. What multiplies to get negative 4 adds to get 3. Negative 1, negative 3. So I'm left with x minus 1, x minus 3, all over 2, x minus, let me see here. X plus 3, plus 3 minus 4. So I have to say that this is a x minus 1, x plus 4. Okay, so how do we get negative 4 and positive 3? We have to have x minus 1 and x plus 4. My mistake, which is going to change this right here. And then we'll see that we have some things to cancel out. So we're left with x plus 4 over 2, x minus 3. And that's about as far as we can go. Okay, the last step, or the last example of this, is about complex fractions. So there's kind of two methods. I'm going to show you both methods of a complex fraction. So a complex fraction, again, what does that mean? It's a fraction on a fraction. So if I take, that means I've got a fraction on the top, a big fraction bar, and then I potentially have another fraction on the bottom. All right, so there are two methods. The first method is to get your answer as the same denominator and then work from there. That's kind of my favorite method, so I'm going to start with that one. So let's pretend that we have a 1 on top plus 1 over q. So what we would say is, okay, right now I've got a p in my denominator and a q in my denominator. So what I'm going to do is I'm going to multiply this one by a q, and I'm going to multiply this one by a p on the top and the bottom. So I have q over pq plus p over pq. So as I continue to simplify, I'm going to be left with 1 over q plus p all over pq. And what you have to remember is this is 1 divided by whatever's underneath. So when we divide fractions, we keep, we change, and then we flip our numerator and our denominator. So really what I'm left with is pq on top, because multiplying by 1 doesn't change anything, and q plus p on the bottom. So again, my goal was to get the same denominator, pq, and then from there I was able to work through and simplify until I got here and I said, okay, when I divide fractions, I really multiply by the reciprocal, which means keep, change, flip. All right, the last example is 5 over x plus 4 all over 1 over x plus 4 plus 2 over x. And so what I'm looking for on this one, and you can kind of, if you recognize that you can use this method, is what's the LCD of my 3 denominators? So since 2 of them are the same, I know that, hey, all I have to do is figure out what I have to do to multiply to make those the same. And what that would be is by multiplying the top by x times x plus 4 and multiplying the bottom by x times x plus 4. So as we do that, and we start to simplify, we're going to say, okay, I'm going to end up getting 5x and then x plus 4. And then on the bottom, I'm going to be left with x plus 2 times x plus 4, which is going to cancel out because I have it twice. So x plus 4 times x plus 4, that cancels out. All I'm left with is 5x on the top, and then x plus 2, x plus 4, x plus 2x plus 8, 3x plus 8. So 5x equals 3x plus 8.